Lesson 5.7 is all about rational exponents. Now there are a couple things we want to go over here really quick. If we have an n index of a radical and say that our base is x to the mth power. Now we've already talked before about how we can rewrite this as our base x to the power of m over n. And that'll be a good one to remember as well. But we can also rewrite this as, again using that n index, we're maintaining whatever our n was before. So if it was a cubic root or the square root, we'd maintain that. So we'd say it's the nth root of x to the mth power. So all three of these mean the same thing. And knowing these properties is going to help us along the way, looking at all these examples. So, moving right along. In our first cases, we need to write each expression in the radical form. We're given something in an exponential form that has a rational exponent. So in this case, our rational exponent is 1/6. So, we are asked to put that into the radical form. So we were given this in our middle form. We want to get it back into our radical form. So we can just notice that our a is like our x in that case. Our 1 was our m, so we'd say to the first power, and 6 was our index there. So we'd rewrite this as the 6th root of a to the 1. Now when you have it here, you don't need to keep the a to the 1. You can just say 6th root of a. So in this case, a to the 1/6 is the same as saying the 6th root of a. Similarly over here we have m to the 1/2 power. Now m to the 1/2 power would be again like saying m to the first power with the radical of an index 2. Now in this case, that 2 index, remember, just means that it's a square root, and that 1 power we don't need to include. So this one just becomes the square root of m. So anytime that you have anything to 1/2 power, it's the square root of that number. Moving right along here, we have the 5th root of b, and we're asked to rewrite that into rational exponents. Now again, looking at our properties, we would say that this is b to the first power and the 5th root of that. So we could rewrite this as b to the 1/5. Again, because we kept our power from before, the b to the first power, and just divided it by the index, so it's b to the 1/5. Similarly over here, we recognize that the index is 2. It's kind of an implied because of the square root. And we have w to the 1, so that's going to be w to the 1/2 power. Again, square root is the same as half power. Half power is the same as square root. Moving right along here, in these cases, we're asked to evaluate each expression, and we have the rational exponents that we are given. So in this case, it's 49 to the rational exponent of -1/2. Now in this case, we can recognize that -1/2 as being two different things. It's either 1/2 times -1, or it's -1 times 1/2. Now if we recognize it as 1/2 times -1, then we would have to rewrite our whole thing as 49 to the 1/2 power to the -1st power. Now again, the 1/2 power implies a square root. So it would be the square root of 49 to the 1/2 power. And as you know, the square root of 49 is 7. So we're looking for 7 to the -1 power. That -1 power just means find the reciprocal of that. So it would be 1/7. And that would be our final answer. Now similarly, if we look at, say we recognized -1/2 as -1 times 1/2, we would have to rewrite it as 49 to the negative 1 to the 1/2, in which case here we would say first find a reciprocal, so 1 over 49 to the 1/2. Again, we recognize the 1/2 as a square root. It would be square root of 1 over 49, which we can distribute to each of those. So square root of 1 over square root of 49. Square root of 1 is 1, square root of 49 is 7. So again, we find that our answer is 1/7. So both ways work, but it's just a matter of which one you are more comfortable with. If you use either of these on the homeworks or quizzes or tests, they will all work. You just want to find which one is most comfortable for you to use. Moving on to our next one, we have 32 to the 2/5 power. Again, we want to recognize that as a power-to-power process. So we can recognize 2/5 as being 2 times 1/5, or 1/5 times 2. If we recognize it as 2 to the 1/5, or 2 times 1/5, then we'd say it's 32 squared to the 1/5 power, in which case 32 squared, if you punch that into your calculator, becomes 1024, still to the 1/5 power. And if you look at your table from before, you'll find that the 5th power, again, we can rewrite that as 5th root of 1024. That is 4. So 4 is our final answer here. Another way to do this then is recognizing the 1/5 first. So we'd say 32 to the 1/5, then square it. 1/5, or 32 to the 1/5 is the same as saying the 5th root of 32, which again, going to your table, shows that the 5th root of 32 is 2. So we're looking for 2 squared, and 2 squared we know is 4. So again, both ways to get 4, both ways to get the correct answer. It just depends on which way you recognize it first. Moving right along here, we are looking at simplifying some expressions with rational exponents. So in these cases, we have 2 different monomials being multiplied together with exponents. So as we remember from our earlier lessons, when it's exponent times exponent with the same base, you add the exponents. So in this case, when we have y to the 1/7 times y to the 4/7, that's going to become y to the 5/7. Now from here, we don't want to leave it in our rational exponent form. We want to simplify it down. So from there, we would say that it is actually the 7th root of y to the 5. Again, remembering back to our original properties. I'm actually going to skip to c, because c is a similar process here. When we have x to the 1/5 times x to the 7/5, that would become x to the 8/5, because we just add together our exponents, the 1/5 and the 7/5. So now that we have that it's x to the 8/5, we could rewrite that as 5th root of x to the 8. So that would be A and C.